morning, monsters. How are you all doing? Well, we did a dream stream last night, and part of that came up the topic of latency or frame rate. And this is such a topic I love. I'm passionate about performance. I'm passionate about things working roughly right. And I figured let's break down what performance or latency actually means in game consoles, because I think it's one of those areas where people have a lot of misunderstandings. So first of all, I'm going to talk about the entire journey from the controller to the comms between the controller and the console hardware. We're going to talk about some of the game latency, and then we're going to talk about monitor and display latency. Very briefly, we're just going to take a trip through this whole thing, and then finally we're going to talk about some of the biology at play, because there is a whole stack, and everyone is always super focused on this section of the problem, and even this section of the problem they're overly focused on one area, which isn't the whole story. So let's dive into it. First of all, controllers. There are cheap controllers and there are really complicated controllers and well-made controllers, and I'm going to talk pretty naively about this stuff, and I'm going to talk about some of the hacks that top-end stuff does, but yeah. Okay, so in the simplest form, a controller is a button switch. Okay, now the thing that most people don't understand about button switches is there are so many ways to build these things. If you ever have to build hardware and you have to order a button or choose a button from the menu that modern manufacturing offers, it's a terrifying proposal. But the thing that basically happens is at some point you want to press this button and a signal goes out of this button, and it's an analog process. And for the button to feel good, it has to have some amount of travel, right? So that's the amount that you press down the button, and that travel is a physical travel time. You know, it slows down the input, and when the button is fully depressed, an analog signal is sent out like that, right? And we detect the edge usually, or the high state of the button in the electronics, right? We detect that. Now the first thing you'll notice, as I say, we lose time to the travel time, and you're like, oof, that's really bad. And then the second thing, if you're measuring the high rather than the edge, you actually lose time in the analog current exchange there. And so what some high-end buttons do, and one of the hacks that happens, is a lot of people actually put the button switch, the mechanism to detect when the button's being pushed, right at the start of the travel of the button, and the rest of the button travel is still hot. But what this means is if the player partially depresses the button, then you might get a false reading. And so there's some very complicated biomechanical work that goes into getting just the right amount of travel that the person feels they've pressed the button, and pushing that signal as far forward in the process as you can to eliminate that latency, and then to do things like, as I say, measuring the edge rather than the high on the analog signal, right? This sounds super trivial, but you would be amazed at how much impact this has, and how a cheap game controller can actually really break that whole cycle. Then once we've moved on from the analog button switching part, you have a whole bunch of buttons on your controller, and if it's well made or if it's poorly made, this can all affect it. But basically you need a strategy for taking all of these button inputs here and sending them over to the console, usually via Bluetooth or some proprietary wireless communication method. And wrapping things up in Bluetooth means you need to wrap them up into these little packets of data, right? Little presents of data for your console. that include, here's all the shit that changed. Now what will usually happen is some controllers, very few controllers do this, this is very naive, will actually, when they register a button input, send data across, as in like, oh, they just pushed button A. But that's quite silly, because there's a whole, you could in theory get a queue and there's all kinds of messy things. So what usually happens is the controller will sample the entire state of all the buttons at any given point and will constantly stream the button state, or it will poll the button state. And that poll is usually just an electronic register, which is like literally measuring the analog signals, because we're trying to break it down as much as possible. And it's going, okay, here's the current state. Now the button may be in the middle of a press, but we don't wait for resolution, because anytime we wait, the system gets slower, right? And then we send off a Bluetooth packet or a communications packet if it's a proprietary thing. Now, this almost never happens in your home unless you've got bad circumstances, but it happens often in game studios. That morning coffee. Bluetooth is a wireless transmission medium, which means packet drop is a reality. So sometimes the message just won't get through. Sucks, right? And then you have to resend the message. Now, depending, if you were naive and you were sending one message every 30th of a second, like if you were thinking in terms of 30 frames a second, well, this whole system would suck. It would be really shitty. And so I'm going to throw arbitrary numbers out here because I don't want to say anything NDA or proprietary about any of the systems I know. But let's say you sample everything 200 times. So every second, 200 controller packets go in between the controller and the console. It's just a thumb suck number out of the air as an example. And that gives us our first in the system sort of gated heartbeat. Now remember, it doesn't matter if the button travel is halfway into this frame or the full way into this frame. All that matters is when this frame actually gets sent. And that in itself is a whole process of sending it from the chip register to the Bluetooth communication, wrapping all that up, sending it over the wire. You have over-the-air latency, which is minuscule, but it is a factor. So much of a factor that for esports competitors, we do actually on the PlayStation, for example, offer a USB communications mode, because that reduces this this wireless comms part of the problem. It's a very, very small part of the problem, but it is part of the latency equation. So as I say, Bluetooth communication between your controller and your device is part of the problem. You can have packet drop. So for USB or sound sensitive stuff, you can use USB comms, because the Bluetooth chip in your controller or the Bluetooth chip in your console is a whole nother chip that all of it does is basically translate these signals across. A little bit of work, but I want to just mention every part of the process, because you'd be amazed at how often a small fuck up in this pipeline screws the entire experience, and how many engineers have to get their jobs just right for you to get that good ass game feel. So we've got the Bluetooth controller stuff. Now we've got the device. Now I don't want to go and dive into the whole explanation of the console, but you effectively have your I/O bus, and on your I/O bus you're going to have things like your hardware ports, but you also have things like your Bluetooth. Have things like your drives, all this kind of stuff, and your I/O bus is going to communicate in, and then between that and the actual CPU, because bear in mind that there's for anything to actually be done by the game, it has to be on the actual logic circuit. You've got your L3 cache, L2 cache, L1 cache, you've got then your registers, right? So that's all of the layers that everything is going to go through from the hardware layer to sort of traverse. Okay, and I'm just sort of laying it all out here. I don't want to go too much into specifics, but then that's not the full story, because what will actually happen is on your I/O bus you will have your device registered. So your controller will be one of the devices that is registered on here, and the Bluetooth will come through and it'll have a device ID or a communication ID in a very low layer of the hardware and the firmware, and it'll pipe through there. And then the software development kit or the firmware, it's kind of a bit of both, but the software developer kit exposes it to the game developer, basically has a call in it that says sample the controller. And this is the mistake that so many people make when they think about latency and when they think about controller inputs. They think the moment they call poll controller or whatever the function is called, that they are getting the game state of the controller. But we've already seen all of the different stages we've already gone through, right? And the reality is, with this poll controller, when you call that function, the Bluetooth chip might still be doing its work. The I/O bus might still be doing its work. The firmware might still be doing its work, and then as you call that function, that's when the latency of pulling it off the I/O bus, going through L2 into the registers and pulling that all out will work. Now, in a modern games console, and actually in some of the old games consoles like Game Boys, which are really well documented and you can actually get some good architecture, what we'll often do, so especially Game Boys, because a Game Boy had the buttons on the actual controller, they would literally wire that physical switch we were talking about earlier. They'll wire that physical switch to an actual hardware register or an interrupt, so the CPU could read it directly when you push the button, which is why the Game Boy had one of the best controller latencies and one of the lowest latencies. But what a modern game controller console can do is, instead of pushing the controller through all of the I/O bus and all this crap like a regular piece of hardware you plug in, I don't know, the peripheral 5000, and it goes through all the states, they could say, well, we know the game controller is the most important thing in the console, and what we can say is the Bluetooth communication channel, which we have devoted to the console controller, because we pre-register of the 8 channels that we have, and we go, okay, well, that's a host channel which we have to reserve. We're going to reserve these 4 channels, and these 4 channels will only ever be a game controller. No other Bluetooth device can ever connect to these 4 channels. Right. Let's put a little wire, and this is a simplification, but let's put a wire from that to a very specific register in the console and basically short circuit this process so we can make that down and shorter and smaller, right? Again, sounds like a lot, but you just need to appreciate just how much goes into this. So now we're in the software layer. And this is the layer where most people start. And it's hilarious, right? Because you think about how much stuff's already happened. But here's the problem. Most people don't write their own games engines. Most people are using Unity or Unreal. Unity and Unreal run on a whole smattering of devices, and because they run on a whole smattering of devices, they have to be compatible with Windows direct input, they have to be compatible with all the different consoles, and the optimization for those specific devices might not be great. You have a problem called lowest common denominator, where, things are happening. Now, I'm not saying that they're all bad or whatever, but a lot of people aren't aware of this. So you've got the SDK, which is the lowest software layer a game developer has access to, and in there is a poll command, which is basically get the state of the controller at this given time. Then what'll typically happen is a game will have, let's call it just a game loop. right? I'm going to be super naive about how I write this, because this in itself could be a whole nother talk. I've seen whole talks at GDC where people just talk about this part. And let's say we got a bit in here that's like, oh, we're going to handle the input. We're going to do logic. And then we're going to render. Okay, that's basically a game loop. So when we poll the input, first of all, one of the mistakes people can make is they can sample the input after doing the logic. So imagine if you put the input sampling here, that means all of this time to this time you're dealing with stale data. And it gets worse, because if you had sampled the input after you had done your game update for the frame, not only is your logic operating, so not only do you have this like full frame sort of tick over for the logic, but your logic is operating on data that is a frame old, right? Which means you're rendering data that is a frame old, which means realistically the cycle, whatever it is, whether it's 30 frames a second or 60 frames a second, your latency is double that, right? And I've got the sad fact is that in some games this can get even worse, right? In some games, between the layers of scripting and various game logic layers and delays and everything, the stage from handling the controller poll, like the polling of the input, to a pixel on screen changing because of your input, can be anything between 1 and 14 frames. And that, when you look at that is insane. There have been AAA games that have shipped with a 14 frame latency. It happens. This is purely under the game developer's control. You'd be amazed at how many game developers fuck this up. There are good reasons for maybe a 2-frame latency or something like that. There are a whole bunch of complexities to deal with, controllers being plugged in, plugged out, network controllers, things like that. But games themselves, regardless of whether they're running at 30 frames or 60 frames a second, can have 1 to 14 frames latency. And that's a big part of game development that a lot of gamers don't realize. And that's why some games can feel so tight at 30 frames a second, and some games can feel a bit loose at 60 frames a second. Okay, so the next issue we're going to get onto is when you are affecting that button change. And this is a bit of a softer topic, and again, this is another whole talk you can go into. And the game has registered the logic, right? Let's say that it is a jump button, right? And this is where the 14 frames latency can come in. If there is a jump button and your character is sort of mid-stride, right? So your character, their feet are off the ground or whatever, and you want the animation to play for a few frames till their foot lands, and then boom, you play the animation to jump, and the animation to jump needs a little bit of wind up where they bend their knees. All right, and that's a whole bunch of visual and audio latency that comes through before they make the huh sound and they jump. And you compare that with like a Mario or a pixel game, like literal Spike game, where straight away the character starts moving. This part gamers are quite familiar with, and this part people are somewhat acquainted with. But I think it's important to mention that game designers and even animators can affect the feel and latency of a game. And if you're doing a game in Dreams, for instance, you should pay attention to how this all plays out and what gadgets add additional latency to your flow, and how quickly can you give feedback to the player, because that's a big part of the equation. But we haven't finished, right? Now that the game has done all of this work, it then needs to send this stuff out, and there is a bit of latency between the CPU and then the vid out and the audio, right? but it's all going to be very familiar, so we can go quite quickly through it. Now, the CPU to the video, when you've rendered the frame, it then needs to go to an HDMI encoder chip, and it needs to translate all of that. And again, on some cheap consoles, like China consoles or whatever, where they're like emulating old SNESes or whatever, this process can actually be quite slow depending on how they've implemented it. So you can get quite a bit of additional latency there. On a modern console, like from a major manufacturer like PlayStation or Xbox or Switch or whatever, Nintendo, you're not going to see this as a huge latency, but on some cheaper devices you will. Likewise, the audio will go to a DAC, which is a digital audio converter, and that'll convert the signal to an audio signal, a little speaker jack signal, right? But the journey's not finished there. We're going to have to split it out into two. Let's do video first. Video, it's going to travel along that HDMI cable and it's going to hit your television and now or your monitor. Now this is something again that people have actually heard about to some extent, but your monitor first of all has a refresh rate, and hopefully that is synced up with your game, right? Because if your game is updating, your monitor refresh rate is different, things get into a bad place. Now there's some modern technologies like G-Sync, which are basically a fancy way of saying slave the monitor to your graphics card and sync them up perfectly to remove this latency. But especially if you've got an older TV, there can be quite a bit of latency in the actual hardware that takes on the TV side that HDMI signal and converts it to actually render, and then it'll often have a layer where it's like, oh, we've got this fancy smart TV guide layer that we're rendering on top of it, and so we're going to add a frame or two latency as we render it. And in some cases the latency measured on these televisions has been awful. Top tip, if you have a TV, check if it has a game mode, because the game mode tends to turn off a lot of the fancy trickery that TVs do, where they like sample the entire screen to sort of balance the colors out, and they do screen overlays and all that. The game stuff tends to turn that off, and it tends to turn off a lot of the color grading that modern TVs try to do. So there's a whole bunch of stuff there. If you're using a computer monitor, tends to be better, but it's a whole stack. And then once it's actually on the TV, it renders and then it comes to your eyeball, and you're going to laugh and you're going to say, Claire, you're being ridiculous, but I got news for you. Your average human response from eyeball to pushing a button, like from you actually making a reaction, we're not even talking about you thinking about what to do, we're talking about automatic reactions, 0.25 milliseconds, 0.25 seconds, sorry. So we are talking human eyeballs are kind of shitty at reacting, and this is kind of why you hear that bullshit argument of the human eye can't see faster than 24 frames per second, and it's like, that's not true. But the human eyeball reaction time in a human is 0.25 seconds reaction to visual stimuli. So there we go, problem there. But we haven't finished. Audio. Now if you're a good little girl or you're a good little boy and you've stuck in your audio jack and you're using a traditional speaker jack and you're going straight to headphones, so you're not even worried about over the air travel from your TV, so you're not worried about the HDMI audio signal, then bam, it goes straight into your ears, and it's super damn fast because that's the speed of electricity, and your speakers are really, really fast in your headphones because for a very long time we've been optimizing audio equipment. And here's the good news, your auditory input reaction is on average 0.17 seconds, so you can react faster to audio. And game designers, when they're making like a character jump, will often make the audio sound play instantly, even if the animation doesn't play instantly. That's good game design. And when we talk about sounds, one of the things is we talk about the attack of the sound, and that's how fast it sort of ramps up. And that will also help the feel of latency, right? Because if the sound starts playing and there's a bit of silence at the start of the sound, or the sound is softly building up, then you're not going to react to it as quickly as a instant beep, or, you know, just a harsh sound. So there's that. But however, if you send your audio through Bluetooth, and I'm going to assume the worst case, and you're sending it to a speaker, and I'm going to assume it's a sound bar, which people do, and then the soundbar is going to do a whole bunch of artificial processing to it, because that's what soundbars do, and they're going to add latency to the sound. And then there's going to be over-the-air sound travel, because sound is one of the slowest things we deal with, and then it's going to hit your ear. FYI, the difference between your auditory and your visual stimuli response is theorized to be because sound travels slower, so you'll tend to see something and hear something at different times, and then because of how your brain processes it, if you see a lightning strike, for example, by the time your brain has heard it and thought about hearing it and seen it and thought about seeing it, it's basically roughly the same time for most times, because the sound arrived at your ears after the light arrived at your eyeballs. And so if you're curious, from a biological point of view, that's why they think that your auditory response is slightly faster. It also helps that auditory signal load in the nerve is much simpler signal when you actually look at how complex the auditory nerve is compared to the visual nerve. Anyway, sounds crazy. But then we've got all of that latency there. If you've got a soundbar, fuck you. Soundbars are awful, or at least some soundbars are awful. And then you can get all that latency. Make the decision to push the button, and we're back at the start of our journey. And isn't that a whole wonderful, long journey? And yet everyone, when they're talking about latency in consoles and latency in games, wants to talk about frame rate. Whereas if you look at the full story from the controller to the human biology to the reaction, you can see why that's so problematic. And you can also see why a Game Boy, which had a built-in screen, so it controlled its screen, had built-in buttons which were electronically registered, has some of the best latency ever made. Like, modern consoles doesn't touch Game Boy latency, because yeah, that's the whole thing. Yeah, soundbars are the fucking worst. They really are. And I hope that has been a little bit of entertainment and education for you all. If you're watching on YouTube, this is a live show we do in the mornings. Come join us over on Twitch. Otherwise, going to check if we have any questions. And so we're going to say ta-ta for now to the YouTube folks. I'm going to go on to a bit of post-stream stuff.